in this session, we want to combine that notion of counting with our truth tables. So I'm going to come back to diagrams.net and come over to our truth tables. And a couple subtle but important points are that when we thought about the order of our truth tables, we start out by thinking, well, there's a preferred symbol. Okay, and what if both inputs were preferred? What would the output be for different operations? And then we said, well, if both inputs could be preferred, then both could be unpreferred. And we did that. And then we considered one at a time if they were preferred. Now what we can do is we can think of, okay, sometimes it's more convenient to put them in the order of counting. Remember, it's critical. Each row in the truth table indicates the values at some point in time. Two rows can never be true at the same time. Okay? So we're just saying that, hey, at some point in time, these could be the values. And at some other point in time, maybe it's these. And it could go back and forth from row to row without any order being required. So what I'm going to do is I'm going to say, okay, while they both could be preferred, I'm going to move that down to my last case. And so I'm going to start off with unpreferred and unpreferred, 0 and 0, thinking if this is a 2's place and a 1's place, no 2's, no 1's gives me 0 kind of thing. And then for my next, so let me actually move this up first. Then my next place would be a 0 and a 1. And if I'm thinking of this as counting. Then I have 0 and 1. That can be a 0. My next case could be 1 and 0. And then finally 1 and 1. So again, I have not changed the logic at all. I'm not changing the outputs with respect to the inputs at all. So the logic is exactly the same. I'm just specifying the order in the truth table that they would be. And again, in reality, when our logic is processing, it can be jumping from any row to any row. Okay. For our not, then I would do the same thing. I would say, okay, let's start out by considering the first row, the first set of possibilities in the truth table as starting out with our other symbol. Okay, great. Now that we have that, we can use this and we can think about one of our first operations, actually not first, an operation what we call decoding. Okay? And in a decoder, we want to have an output for each set of possible inputs. Okay? So what I'm going to do is I'll take one of these. I guess it doesn't really matter which one. And I'll copy that, and I guess I should probably come over here and start a new tab for this, and I will call this decoder. I'll paste my truth table in here, and what I'm going to find is if I want a separate output for each possible combination of inputs. So if I have 2 inputs, there's 4 combinations of values, so I'm going to need 4 outputs here. So I'm going to copy that and paste that over here, and I'll paste another one in over here, and I'll paste another one in over here. Remember, outputs on the right-hand side of the vertical divider, inputs on the left-hand side. So I've got 2 inputs and 4 outputs now. Therefore, I'm going to call this a 2 to 4 decoder. Okay. 2 inputs, 4 outputs. And what I want is one of the inputs, I'll say this one, I'll have that be preferred for this case, this combination of inputs, and this combination only. Okay. Which means this combination of inputs I'm going to designate with this output so that it'll be preferred only in that case. Again, next combination of inputs will be my next output, and so that would be preferred only for that combination of inputs. And then finally, my 4th combination is my 4th output there. So I'll just call these something different. So I'll call these D, E, and F for now. Great. So there's the truth table for my decoder. And now can we implement this in Circuitverse? What would it look like with nots, ands, and ors? So I will do the good old Windows Shift S, take a screenshot of this and save it. I'll call this 2, I can't use a colon in the file name, but I'll do 2 for decoder. Save that, then I can close out of that, and now I can come back to Circuitverse. And I'm going to create a new circuit. I'm going to call this 2, and I believe I can use colons in Circuitverse's names. So I'm going to say 2 to 4 decoder. And grab my image annotation and input my 2 to 4 decoder truth table. And that doesn't look too bad, good enough for me. So I know that I'm going to have 2 inputs, so maybe I'll start there and say, okay, here's an input, here's an input. And I'm going to have 4 outputs, so I'll say outputs 1, 2, 3, and 4. All I have to do is figure out, okay, what goes on in between these. So what I'm going to find is that if this is my first output, and I guess I should probably label these C, D, E, and F. And of course that means then that this is input A and this is input B. So the good news is it's really nothing different than we've done before. If we have multiple outputs, we just consider one output at a time. So I'm going to focus on output C. And then I'm going to do like I've done before. I say, okay, when is output C in a preferred state? And there's only one case where it is, and that's when A is not preferred and B is not preferred. Oh, okay. So that means not A and not B gives me my preferred. So come over here and I say, gates. An A and a not and a not. And so if I have not A and not B, that gives me my C output. And we can verify. I've got 0 out because both my inputs are 1, so that is my 4th row in the truth table. If I change A to 0 and B to 1, then that's my 2nd row in the truth table now. And I should get a 0 out. If I change A to 1 and B to 1, let's change B to 0. So now that's my 3rd row in the truth table, where A is a 1, B is a 0. I get a 0 out. That's what I was expecting. And so finally, if A is a 0 and B is a 0, then I get a 1 out, as I'm expecting. And so now I can simply do the same thing for D and say, oh, D should only be preferred when it's not A and B. So I can put another and in here with a not and do that one separately.